the technical session uh, on Sunday Meet. The different ideas and different knowledge at different fields. Okay, so here we have our guest, Mr. Sarang, who is currently working in a Qualcomm. And sir, you can introduce yourself better, I guess.
Uh, yeah, you can, every one of you can call me Sarang. I would feel more comfortable with that, right? So I did my engineering in like 2013. Like I'm a 2013 pass out. Then okay, so always being passionate about like electronics, embedded system, and VLSI technology, I decided to like actually go towards that field only. It was initially really tough. Like I think I belong to a college where it offered a very nice placements and all. After giving like I would say 120 or 130 companies, and brutally rejected from every one of them. So so yeah, I joined a startup. And the startup was in Bangalore, working basically in electronics. I joined in as an Android Java developer, uh, but I soon realized it is not my field. Being an electronics engineer, I always wanted to be into electronics. So after 1 year, I joined Robert Bosch Engineering and Business Solution, where I was working for hybrid electric vehicle, basically for customers like Ferrari and um, Volkswagen. Yeah, these two were my primary customers from which I work from Robert Bosch. I spent there like 2.5 years there, worked with a lot of uh, lot of automotive things. Soon realized that that is also not what I would like to pursue in life. Then I joined Qualcomm. Qualcomm I joined in as into a product line known as earbuds. So like I joined for like voice and music chipsets. So we basically work on voice and music chipsets, and the primary customer being right from small customers like Bolt to Bose. Like yeah, very much like I can say that if you are using a wireless earbuds, possibility is Qualcomm has done a chip for you, or Qualcomm has provided the specification in Bluetooth for that. Later to that, I joined in as an application developer for the voice and music chipsets. Then I recently switched to firmware development. Now I am a security engineer. Basically, I look for like my job profile now involves into the looking for the security aspects of the chip. So that later, but like you can just imagine that uh, I'm I'm just changing things for the like basically I'm moving to the stuff which I like really. And yeah, it's like I decided in my engineering that maybe someday I will work as a firmware engineer. Now I'm working as a firmware engineer. It took like around I guess 8 years now, but I feel it was worth it. So yeah, now my profile is basically I'm responsible for the security of the chip, which is basically an earbud. um, but yeah, that's all about myself. Like, yeah, please, like, interrupt me anytime you wanted to ask. Like, okay, first thing is, I would really like to say is it's never late to basically whatever you want to choose. It's never late to do that, right? Like, you can imagine that I joined as an Android Java developer, and now I am a firmware engineer. So it's like corporate world is like really different, and you can really be doing one job today and doing a completely different tomorrow, right? So I can tell you that my second job has nothing to do with my first job. My third job has nothing to do with my second job, and my whatever profile I'm into is has nothing to do with the profile I have been to previously. So what is helping me out is basically strong engineering fundamentals, and that is like that is the key for everything. I don't expect everyone to know each and everything, every part, but one should be really strong in the practical, and that's what I feel key has really helped me to to achieve everything. So Yeah, that's
That's a wonderful introduction, sir. I can say you have just defined everything precisely. I can say so. So let's ask you some of the questions which are in my mind, and some of my friends also share me that,
sure.
like in like the programming is generally we used to say that computer guys doing and college time, like, so nowadays the programming is essential skill for any EC guy. So how someone can approach to that the programming? Like, can you just elaborate some more?
Yeah, so depend whether you really like programming. Okay, so it's like I'm getting an echo. Sorry, Kathan. Yeah,
Okay.
yeah. So it's not necessity. Okay, knowing programming is like really helpful. So I can tell you like there are different kinds of job in EC world, which I think not many times are being talked about, right? So I would say like you can be into a front end or you can be into a back end. Front end are the guys. Okay, so let me put in this way: if you wish to program, you can do the programming. Okay, if you don't wish to take the programming field of it, you want to take some other field of the EC, that is also fine, right? And what I've seen is programming is only a tool, like which helps you to do certain things, right? But it's not like you will be always using C, C++, Java or something like that. You might be using something known as model based design. So model based design is something like MATLAB or LabVIEW and all this kind of stuff. Okay, but these things all are being required only if you are kind of developer. Okay, if you are into certain field which does not require you to program, maybe you don't need it. Okay, so you can be a kind of analog engineer where you make the circuits, right? So you don't need to know the programming of that. You could be a tester. Okay, you could be a physical design engineer, you could be a system verification engineer, you could be lot of other things, you could be an emulator engineer, emulation engineer. Lot of this stuff will not require you direct programming. Okay, lot of this stuff will require you knowing the tool. Lot of this stuff will require you to understand the fundamentals and having like that mindset, right? And what I feel is, even though I'm not a like die-hard programmer or anything, like I won't call myself as a programmer, uh, because that's the only way my hardware understand the thing, right? So if you
Yeah.
so if you say that like whether I will be able to solve lead codes and all, maybe I might not be. Okay, maybe I might not be as good programmer as you guys are. Okay, but it will help. Like if you are making test automation and uh, CI scripting and all those things, it will surely help.
Okay.
But
So my
you have to
next
choose.
question
Yeah.
is on your company. Like in Qualcomm, we used to uh, see in the advertisement of like this earbuds and kind of. So what actually Qualcomm does? Like it designs the chip or it designs some sort of the IP kind of. Can
Okay,
you tell me?
yeah. So considering Qualcomm, right? Qualcomm is basically a fabless technology company. Okay. So what do you mean by fabless? We don't manufacture anything. We actually don't make anything. We only make technology. Okay. We make technology, we sell that technology, and we make money. Okay. So you will find that Qualcomm as an manufacturer does not have any end product. Okay. You can say that yes, we have the chips and all, right? But the main business of Qualcomm is basically being technology and the patents.
So it's in a communication business kind of.
It's okay. I will give you like a lot of things. So Qualcomm is basically made by engineers, made for engineers. Currently holding 140,000, 140,000 plus patents, active patents. And if you are using a phone, you are paying a royalty to Qualcomm. Cell phone, you are paying a royalty to Qualcomm, right? When
Yeah,
you
get
purchase
it.
phone, you some percentage of the phone is being given to Qualcomm because you are using Qualcomm patents. Okay, so that's how it works. So anything and everything related to wireless, Qualcomm is into. Okay, so main thing basically people know about it is basically a Snapdragon chipset, which is like most of the Android phones are using and all, right? But apart from Snapdragon chipset, we have like modem chips, right? Which goes into iPhone, which goes into like every phone. CDMA was Qualcomm's technology, so there was no phone which had a CDMA and did not pay Qualcomm. Okay, so basically the thing is once foundation for research, and basically these guys have the capability to convert your idea into a chip, right? So
Okay.
whatever you're thinking, your complete patents or complete things, people are like basically converted into a chip. And I can tell you a basic scenario how earlier used to happen 5 years down the line or 10 years down the line, right? So maybe you have seen the headphones or mobile phones which are like really big, and 10 years down the line there was no wireless earbuds or something like that which you see, right? So what used to happen is you need,
Yeah.
10 years down the line you were having different chips for different things, right? So I can give you an example of an earbud. An earbud is like a wireless earbud product. You can see the wireless earbud as a product where you have a Bluetooth, right? And every one of you must have use it at certain point of time, or you have known about it, right? Like you have a earbud and you put it in your ear and wirelessly connect to a Bluetooth and everything works fine, right? So if I divide this complete structure into smaller parts, right, what it will have? It will have something, a processing unit for Bluetooth control, a processing unit for digital audio processing, right? So you can call it as DSP, processing unit to capture your analog input data, a power control unit, and also you can say like a lot of proprietary stuff. But you can see that, right? Um, all this different stuff, uh, digital signal processing, Bluetooth, analog to digital converter, digital to analog converter. These were initially being used as a discrete component, right? So if you have been using something like a breadboard or something, and if you have made certain project, right? What you initially used to do is like you take a ADC chip, you take a DAC chip, you take a DSP, you take a Bluetooth chip, and combined it together into a single PCB, and then that becomes your basically an earbud. But with the advancement in technology, everything is a single chip solution. So it's known as an SoC. What is an SoC is basically a system on chip, a single chip doing everything. So a modern earbud, what you're using currently, and it's having at least 8 to 10 CPU inside it. Okay. When I say a CPU, it could be an ARM core, AVR core, or like that core. Okay. So the modern earbuds, what you're using currently, is having 8 CPU at least. One of the CPU will be like we have dual core CPU for Bluetooth, we have a dual core CPU for DSP, we have a dual core CPU for power management, and these all CPUs are working independently, right? And there is a one master CPU which is basically controlling each other CPUs, right? And so if you see as a complete thing, you will find only 0.5 mm by 0.5 mm single chip. But if you find it inside really, you will have ADC, DAC, power management, multiple CPUs, multiple DSPs, multiple architectures embedded inside a single integrated circuit. So integrated circuits design and technology is basically being driven by Qualcomm, and then they make a chip. And how they earn money is basically they sell the chip for certain amount of time, certain amount of money, and every technology you use, you have to pay the licensing fees for it, right? So if you're using a Bluetooth and you are using there in Bluetooth for the communication medium, there is like different encoder decoder licenses, like SBC being the normal encoder decoder. So that is like highest latency and all. It's any product can be called as a Bluetooth earbud device only if it uses SBC. encoder decoder. It's a decoder encoder protocol, but you can have something like aptX adaptive and aptX low latency and all those things. These are like Qualcomm proprietary protocols for wireless. And if you are having a Qualcomm phone and you are having a Qualcomm earbud, it gets connected into aptX. So aptX adaptive or aptX low latency or whatever codec it has, right? So for using that codec, people pay licensing fees, right? So lot of licensing fees is being on the top of the chip. Licensing fees also being provided as a from Qualcomm. We give something known as application development kit along with the chip. You take this chip. This is the application development kit, which is having the entire software. Using this entire software, you can just build a plastic around it and sell it. Okay, so it is known as reference design. So a lot of our customers like Bolt or very small customers, like these customers cannot afford to have their own research and development. So what they do is basically they buy the chip from us, put the plastic around it and sell it. Okay, so
Right.
Like,
So
yeah,
you have
that
mentioned,
particularly like I like that they put the plastic around it. So like that seems uh, particularly like perfectly fit for the purpose. I see.
yeah, it's perfectly, yeah, like you can see from that perspective is really great, right? So but you would see that lot of customers having similar kind of design or similar kind of audio. You can
Yeah,
actually not, you cannot actually differentiate between them. And yeah, it's okay, but like price margin is like really high. So I can tell you that a single chip of Bluetooth, we sell it to customer for like a very small customer. We sell it for $3 a chip. Okay, $3. We make it at 20 cents a chip. Okay, and that $3 a chip, whatever product it goes into, it gets sold as an end customer around like I guess around 3,000 rupees. Uh, like so, you can consider like around 3,000 is like I don't know, calculated. So it's like we make it in cents, sell it in dollars. Like $3 is like around 300 rupees or something, and the end customer basically buys it at like 3,000 or 4,000 rupees.
yeah,
yeah,
So
profit.
you can see the profit margin, and the bigger the profit margin, the bigger the employees get paid. So
Yeah. So coming to a similar question, you said earlier that you are a security engineer right now.
yeah,
Basically, if we talk about earbuds that you're working on, so
yeah.
there are many small CPUs and chips. So, like, are the chips or the hardware hackable, or it's about the reverse engineering possibilities that you have to take care of? Or
So yeah, so I can tell you, there is no electronic equipment in the world which is not hackable. Okay, so what is the term we use in security, right? The term we basically use in security is the amount of time or the resources required to hack a chip should be so high that it defeats the purpose of hacking the chip. Okay, so ultimately you're going to hack the chip, but the amount of time and resource you will put into it uh, will the cost of putting that will be much higher than the cost of actual information you will get. Okay, so that's how the real world works. Even the Amazon server works on the same way. Everything is hackable, but resources and the amount of time you will require to hack that thing will be like too much. So that's there is no secured system as of now in the world being made. Nothing is made which is not hackable. But yeah,
yeah.
okay.
So, I want to ask that what was your first project? Like we can say that it's in like
okay, so there was like there is a basic perception that the engineering project and the industrial projects are similar, right? It's not true. Like in the academics, you actually make from really basic stuff. You start from like choosing a microcontroller processor, you choosing a PCB, this thing, that thing, and all those things. In industry, you are a very small part of a very big organization, right? I can tell you, like, if you are working into industry, lot of times you will be amazed that you are able to work years and years and you don't know what you are working on. Okay, that is a real possibility. I can really tell you that. Like, you could be an expert in a single field, right? But you might not know end-to-end system. It's really really difficult to know end-to-end system, right? So initially when I started my career, okay, so I joined a startup because of my final year project, right? So in my final year, I was making a application on Android, uh, which was capable to control the hardware, like a pick and place robot, and I used Google Server to recognize my speech, and the year was 2013. So I think that was the technology was pretty cool at that time stuff, like 2013. I can imagine now everyone, now I think everyone have that, like Amazon and Google, everyone is having it. But I just thought of, like, I just took the APIs from there and then made a pick and place robot, which was capable of working on voice, right? So because of this project, I got an opportunity in a startup, because like the startup guys were like, it's not possible that you have made it. They have given me 2 days to showcase my project. So I just like made a complete project in front of them, because I have to reassemble that, and just reassembled it, and they offered me a job. The job over there, we're working on something like tile. If you have heard about tile, tile is basically a very small technology device. You can note it down. It was, I think, Bluetooth specification 4.3 or something, or 4.1. So the Yeah. So the idea behind it is like, you can keep that small Bluetooth chip along. Like, it was working on a coin cell battery, and the idea behind it was like you can put the coin cell battery along with the Bluetooth chip and keep it along with your previous precious items. Okay, so like you can keep it in your wallet, or you can keep it in a chain, or like that, and it is always connected to your phone. And whenever that goes away from you, basically you get a buzzer either on phone, or you get a buzzer on so it was, I think, find me profile, and you can use this same thing to find anything getting lost or anything like that. So I think even Apple has it now. Even Apple made something similar, Apple Pods or Dots something. But I think when I started, the technology was not that matured. So like we faced a lot of power issues
It's
and
in the initial stage.
all those things. Yes. Now I think it is being matured, and like you can actually have a lot of it's a wireless sensor network, so it can detect any.
There
Uh,
is a term like called ZigBee, loraWAN. So it's a variant of Bluetooth, or it's a different.
no. Okay, ZigBee, LoRaWAN, and all those things is okay. So you have to understand that there is of a spectrum of air which you can use freely without paying any royalty, or which is not being used by the government, right? On that spectrum, you have different communication technology. Like you have an Wi-Fi. Okay, you can work a Wi-Fi on 5 gigahertz. Okay, similarly, Bluetooth works on 5 gigahertz, right? Now, how, if they are same, right? How they are basically able to work together, right? That's the thing. So Wi-Fi may be having a higher bandwidth, and Bluetooth having smaller bandwidth, and all those things. So all this thing like ZigBee, LoRaWAN, Bluetooth, Wi-Fi, they are using the common open space uh, bandwidth to communicate with each other, and avoiding each other. Like your ZigBee is can communicate along with another ZigBee, avoiding Bluetooth and Wi-Fi. So you have an open space, and your protocol basically use that open space in certain manner to avoid interference from your other wireless chipset like Bluetooth. So they, every one of them is using open space. So it would be like 2.5 gigahertz or 5 gigahertz or even 6 gigahertz band. And using the same band, they are actually able to like actually do the communication and all. It's a new, like it's a good technology, um, and knowing this technology is surely helpful. But I have always felt like using the technology, like you will find a lot of people who know how to use the technology. You will find very less amount of people who can actually make that technology work, right?
Yeah, the
So
exact kind of application, like which application they are using and utilization
yeah,
kind of.
so yes, so no, like what I would say is in the industry, if you see, right, you will find lot of people who are good at application stuff, right? You will find, okay, you have a problem statement, and you, in order to solve that problem statement, you will find lot of people who can solve that problem statement using certain specific technology. But there will be very less amount of people who will actually change the technology according to their need and make it something different which is not commercially available, and make a IP out of it, and then
Like
make.
design your own kind of.
Yes, so what I feel is like, um, so a lot of time what is always hidden from everywhere, right? What I feel is, it's my personal opinion, right? You will find lot of good tutorials on like how to use a Bluetooth, how to use a ESP32, how to use an Arduino board, or how to use an PIC32 board, or like all this thing, you will surely find it out, right? But you have to just, they are promoting that stuff only because they want to sell that, right? No one is going to tell you what is going inside ESP32.
Yeah, true.
uh, no one is going to tell you that what is going inside an AVR CPU. No one is going to tell you that, like, so the things which are hidden, right, and known to very less people is very much valued. That's my
That
concluding this
we
area.
need
Like,
to personally find out that on what.
it's like personally find it out, or like there are like lot of specifications. Like when you say you are using a Bluetooth, right? So there are like different communities who make the specification, and it is all open source, right? If you just go to bluetoothsig.org, bluetoothsig.org, you will get a entire specification of your own Bluetooth chipset, or how, not chipset only, how you can make your own Bluetooth. Okay, if you're making a product and it has to be called as a Bluetooth product, what specification it has to follow? Because when I am going to communicate with you, right, when I am going to communicate with my earbud with your earbud, yours might be some Sony, mine might be some XYZ, right? And I don't know whether my communication with you will happen or not, right? So both of us has to like has to follow certain specification while making the design, and this specification is being decided by SIG. Okay, and if you actually know specification, if you know, like, it's all, Bluetooth is basically a complete protocol stack. You have from physical layer to application layer, all the different layers are there, right? And different layers, different protocols are there, and different protocols, different intrinsic things are there, right? And people have spent their life developing the specifications, right? So
It's a lot.
I can tell you that knowing the internal things, like, I have seen a lot of resumes talking that they know Bluetooth, they know, they have connected some light fans with that, and then connected an application with that, and all those things, right? I feel that is something what company wanted you to see, right? But whether you have gone to the specification, and if there is a need that I want to modify that thing in a more power constrained manner, whether can you do it modifying the stack, right? Can you go to that data link layer and change the protocol such that it is doing something which is not possible by someone else, right? Can you go to that network layer and make some changes into that, make your own protocol, make sliding window better, you make something better in that networking protocol, and then you are, instead of using a TCP, you are able to get all the data on UDP, and basically you are able to reduce the network traffic. Can you do that? So that is something which will come. uh,
So the next similar of this really to be required to
yeah.
become a full-fledged knowledge on this embedded, so we can design our own things like that. So with software knowledge,
So
fundamental or
okay.
anything we need.
Okay. I won't say, like, even after 10 years down the line, I wouldn't say I'm an expert. Right. I'm still learning. Okay. I'm still learning as you guys, right? I'm still going through a lot of things, right? I'm still now I am being put into something known as a C5E21 core. So you can even see that a C5 is a company who makes a RISC-V cores, and absolutely I have a zero knowledge about a C5 core, right? But I have been put into that thing, right? So like you have studied an 8051, or you will study an ARM or AVR, whatever controller you will study, right? The same way I'm opening the books, I'm seeing the data sheet, I'm reading from that, and that's going forward, because that I haven't learned anywhere, and it's not possible to know. Okay, so being an embedded engineer, you might not look. The embedded is also very big field. Okay, really, really big field. You can be an wireless, you can be an lower stack developer, you can be an upper stack developer, you can be an verification engineer, you can be an application engineer, you can be a Python script developer. Okay, you can be into different
Uh,
industry altogether.
in student perspective, what we need to like to.
Okay, in student perspective, I would say that keep your basics like really strong. Okay, some of the subjects I use day in and day out from my engineering, I can tell you, is if you have studied embedded system design, basically an analog to digital converter, digital to analog converters, and basic CPU structures like 8051 or AVR ARM or all this thing. Okay, then having a knowledge about analog part and the digital part, digital electronics. From semiconductor perspective, I would say you cannot separate an VLSI and embedded, right? So you need to know, and you need to understand and VLSI design, how the transistors are being made, how why they are being made, what is, and there are like different things into VLSI also, right? You cannot say that you have only used ASICs or integrated circuits, right? You have to also understand FPGAs, right? Field program gate arrays and CPLDs and all this thing, right? Because the FPGAs will be used for emulation and all the stuff, right? Then you have basically a lot of being into only software part of it or the firmware part of it. You might need to know C and data structure, right? Because it's very fundamental things to basically do it, right? But a lot of times I see is people get confused between like um, heavy coding versus embedded coding, right? I always tell my junior that I am not going to accept the code which I don't understand, right? I'm using 3 times star, 1 times plus plus, and 4 times this thing. The code is really difficult to understand to me, right? Once you are gone, who is going to put the head over there and understand the thing, right? uh, so industry follows a different practice that it should be more readable and all those things, right? So I would say C, VLSI design, digital electronics, embedded systems, uh, and then you can take the specialization, right? You, if you want to go to microwave or something like that, or you want to go to networking, embedded, and all those things. But these things will like really be essential, like knowing C and electronics and digital electronics part or instrumentation part is really really base.
So the heavy code is like CS people in EC job or EC people in EC job. There is a two
So
kind.
like I can tell you both the examples I will give you, right? Both the examples I will give you, right? uh, okay, so there are different kinds of developer involved, even when you are developing a chip. So everything you're writing may not be used inside the chip. Okay, there will be lot of softwares which you will write and which will never go inside the chip. Okay, so you have used an IDE, an integrated development environment. Many times you might have used an 8051 IDE or AVR IDE and all those things, right? So that IDE also has to be developed, right? So there will be people sitting around who will be making that IDE. Then whatever chip you are making, you cannot afford to test that chip manually, right? You need to have the automation, right? There will be like thousands of people putting their code onto a stream, right? If you have seen, if you know GitHub and all, basically there is a stream, or basically a flow on which you put your code onto the stream, right? So what is the thing is, you need to know Python for developing the automation scripts, right? So whenever I put a new feature onto a chip, I need certain amount of Python script which will go to the server. I have the hardware connected to the server, and that it will run the automation test case on top of it without knowing, like without manual intervention. So usually in industry there are three levels of testing before, like there are various levels, but I can give you, like there are, like we follow a three level test. One level, first level is basically known as smoke test, second level is known as nightly test, and third level is known as regression test. Okay, so whenever you push your change into a stream, whenever there is a big code database, on the code database, whenever you put your change into the database, first thing happens is smoke test happens. So smoke test is basically a very essential the product, and if they are failing, means that smokes is coming out of your chipset. Okay, so I
Yeah.
would say like there will be like 20 to 30 smoke test, then there will be like 100 to 300 nightly test, and there will be like 800 to 1000 regression test, like they will run on every weekend, right? So all these test cases, all these things will be, even they will call as a tester, they are actually responsible for writing it down language. Maybe it will be C++, it will be Java, it will be Python, right? uh, they electronics, but not necessarily they are going to write a C code, right? They are going to write C++ or Java or Python code to help the product better, like to make the product better, right? So I've seen usually the computer science guys, usually they take the stream which is involved in like tools or like this kind of stuff, and usually I've seen the electronics engineering guy taking the programming of the chip on top of it and all this thing. But I've seen a lot of good computer science guys taking the chip software also. It all depends upon your interest and how what skill set you have. So yeah, you so it's not like we don't use Python or C++, or yeah, you use every language over there, but it not necessarily go onto the chip. Oh,
Got it. And the another one is like one of my friend working on the analog AI project.
uh-huh,
I
uh-huh,
mentioned you previously.
yeah,
So, so his project is based on the analog VLSI domain.
yeah.
So in industry, these people we cannot find, I must say, and the analog
So
VLSI and the
okay,
digital VLSI two domain, right?
yeah.
So, can you tell more about it?
So if you see a world around us, everything is analog, right? And the fastest thing we can do is like digital signal. Like every time you want to do anything, anything is, it has to be understood by a computer. It has to be converted into digital part first, right? But it is not as simple as like you have an ADC which will convert everything into the ADC, and it's not as simple as DAC which is having the conversion into digital to analog, and your job is done, right? It is not so straightforward, right? So in a chip there is basically two main part: an analog part, which is like all discrete components, all the things which cannot be made using digital, right? So once I say digital, what comes into your mind is basically a flip flop, a register, shift registers, or like sequential circuit or combinational circuit. Basically it's the digital thing. But lot of things you cannot make using sequential and combinational circuit, right? You cannot make an amplifier using sequential or combinational circuit. You cannot make an DAC using sequential or combinational circuit. Okay, you cannot make an antenna radiation and all those things using sequential or combinational circuit. So you still have to use an discrete RC component, like you still have to use a resistor, capacitor, inductor, and all those things to make a circuit, right? So this thing, the discrete component part is basically an analog part, right? Which usually is 20 to 30% of the chip, right? I would say, like, if you classify the chip into different parts, so I would say like only 20 to 30% part of the chip is analog. 60 to 70% is basically an digital part. And the reason you find very less is basically there are very less people working in that field. Okay, if you really want to, like, I would say that if you are seeing into semiconductor, Texas Instrument, Analog Devices, these are like the pioneers of working who are working in analog domain. If you're seeing for the digital part, then I would say Qualcomm, Samsung, Amazon, Google, all mostly working on digital part, right?
Yes.
So
So the like computation is mainly done in a digital form. Like there is a different
it,
models
it
of the network
yeah,
available. Like
yeah, I would say like competition is always done in digital. There are different kind of problem you have to solve, right? If
yeah,
you want to make an impedance matching circuitry, whatever you do in digital, nothing is going to help you out, right? Uh,
what's the possibility that the computation can be uh, done in analog?
It has been conventionally being done in analog only, like cathode ray tubes and all, everything was being done in like analog only. It got shifted to digital, and because of the advantage of digital, it is going to stay digital, right? And
My friend
and
Raj can tell more about it. He's actually working on it.
oh, okay.
Raj,
Hello? Hello?
hi.
Huh.
Can you explain more about it?
Actually, sir, what I saw, sir, in industry nowadays, sir, that
Hmm.
nowadays, recently NVIDIA launched a graphics card, sir, 30,
Yeah.
3080 Ti, 3090, 30T.
Uh-huh.
So, sir, in that I saw, sir, they were using PAM4 memory, sir, to obtain a throughput of 1 terabyte per second, sir.
Okay. Okay.
And actually, I also saw that, sir, nowadays the chips that are developed, sir, by Apple,
Uh-huh.
even in graphics card, even AMD, Intel, what those guys are doing is, sir, they are increasing the physical die, sir,
Yeah.
silicon die.
Yeah.
That case, one digital is now limited, sir, because uh,
No, like once you're increasing the die size, so percentage amount is going to be same. Okay. And the electronics always follows, like it has been still following the Moore's law still, right? The current technology what you are taking on, I think it's like 3 nanometer or 4 nanometer is something which we are working on. Qualcomm is already, like, all the latest customers are already working on like 1 nanometer and 2 nanometer also. So the amount of transistor you are putting into a physical die has been increasing tremendously. Like I think every 4 years, the amount of transistor basically put on the die is out of it, right? So what is happening is when you say a 2015 chip with 5 centimeter by 5 centimeter and the 2019 chip with 5 centimeter by 5 centimeter, it's the 2019 chip is basically a twice of the 2015 chip, right? So you can put the amount of transistors into the 2019 chip has been basically doubled. So what you are doing is basically you are trying to accommodate more and more analog and digital part. So suppose in 2015 you were able to put only 100 transistor, so 100 circuits basically you can say. So out of that maybe 30 circuits were for analog and 70 circuits for digital. In 2019 you are able to put 1000 suppose, so basically 300 for analog and 700 for digital. So in that way, analog circuits or analog part of the physical die has increased, proportionally same, like 70% is still digital and 30% is still analog.
Yeah, so like yeah, you just talk about the VLSI, and I just like to say that recently, like I don't know what is the nationwide condition, but in our region, for particularly electronics branch, there's a boom in placement in like VLSI domain. So when we entered the college, we just heard about that. If you want to go into some like a good package and good placement, whatever you want to say, then you should be taking VLSI, and for VLSI you should be taking digital electronics seriously. So yeah, now we know that there are two parts of VLSI, that it's an analog too and digital also, but the common conventional suggestions that we get are like, if you want to go into VLSI, you learn digital electronics properly. So that's the only key, like something like that.
Yeah,
And in
so
that
So
also,
yeah,
DFT, like testing, is mainly concerned by them, not
so
design.
what's behind the VLSI boom, and that causes this type of
okay.
like
So
hype?
I can surely say you that, man. Like we are we are into an era where we are not getting resources. Frankly speaking, we are having scarcity of resource, so that we have to wait for like till 6 months for a resource to join, right? And whatever questions even we are asking, right, it is all basic fundamentals of engineering what you have studied. We are not like, even I have seen my friend, he's in Samsung. He was telling me that a very basic question, like I have 10 address lines, how many address locations I can connect to, right? Suppose I have 10 address lines, so basically I have 2 to the power 10 different addresses to which I can connect to a memory, right? Because every bit is basically 2 bits and all, right? So this question, I think, like, he rejected 12 people. Okay, they call themselves as VLSI engineer, having 3+ years of experience or 5 years of experience, and they really don't know that if your microprocessor is of basically third 16 bit of address lines, you can connect 2 to the power 16 memory location. This is you have studied in your engineering. This is the base of everything, right? And people don't know it, right? And this is the situation, like we are like Samsung, this is the same situation in Qualcomm, and I think a lot of industry you will find the same situation. So there is lot of openings, there is very less amount of people. The reason behind it is really difficult to enter the stream, right? Because like lot of time, we require very specific skill set, and if we don't find it on your resume, you are not being shortlisted, right? So I can tell you, like, different profiles of an engineer. Like it could be an FPGA engineer, right? You could be an system verification engineer, you could be an analog engineer, right? So digital design engineer, you can be a firmware engineer, you can be a middleware engineer, you can, and all these things, keywords what I am saying. If you really are interested to enter into semiconductor, what I would really suggest you is just go to careers.qualcomm.com, 2+ years of experience, and whatever fields you see, right, you will be able to find like hundreds of jobs over, and just see, just check. Okay, VLSI engineer, DFT, VLSI engineer, they are calling for PD physical design, they are calling for SVE, system verification engineer, or package technology, or EMI EMC. What are the skill set they require? Basically every job profile will tell what skill set they require. If you know that skill set, it doesn't really matter that whether you have 1 year of experience, you don't have a experience, or you have 2 years of experience, or 5 years, or 10 years. If you have their skill set, you will get placed. That's the key, right? But the problem is people don't know only that there is a job profile like that, right? So yeah,
Mhm.
it has been becoming difficult for us like that.
Yeah.
So I think
So like I guess concerns. Okay. So now, like the next question that we had in list was like uh, people who are in final years, like they imagine about how the corporate life would be like in a technical company. Uh, like what would be the company structure, and sometimes we hear rumors like you'll be still student, like a student, till 2 or 3 years of experience, and you'll be getting assignments and all that, something a similar thing. So what actually is a company structure in a technical company like yours?
Okay, so there are different companies, there are different things, there are different processes, and every company is basically different. Every company is basically based on different fundamental core technologies and core things. Okay, so I can tell you, like, not everyone who is working in a company is maybe as smart as you as well, right? Okay, that is the harsh reality you have to accept, that maybe the other person may not know as much as you do, maybe fresher know better. Okay, but you have to also accept the fact that maybe he knows way better than you, right? And so it's all it's all a learning phase and all this thing, right? So lot of times what happens is, I can tell you, like, my first company when I joined startup, it was like, we want to do, right? I was like only developer, along with me one diploma guy was there. And the next day onward, there was no training or anything. This is the thing we want to do, we don't know anything about it. Okay, you choose the chip, you choose the board, you choose whatever you want, you scrap your head, you whatever you want to do. Okay, but we want this,
uh,
right? And that is like a good part also and bad part also, right? Good part is you are really really free to do whatever you want to do. Bad part is the things which can get solved in like half an hour or something will take maybe 15 or 20 days to get it solved, right? Because you don't have anyone to ask questions to, right? So you don't know what documents to refer to, you don't know what things you are going to put into. Suppose I tell you tomorrow that you have to develop a Bluetooth 4.3 chipset, basically Bluetooth 4.3 product, and you are completely blank about what is Bluetooth 4.3, right? On the internet what is Bluetooth 4.3. Okay, then you will see that, okay, some IDE has to be used. Okay, what is this IDE, whether I can get the license for it. Then you will try the hack the license and all this, like, it will start from that thing. Okay, in corporate it will not be like that. Corporate, the structure is really really fixed, right? You will be assigned a very proper job, you will be given a training, like what is the procedure, what is the thoughts, what we are developing, and all this thing. And usually in corporate nothing is developed from the scrap. Okay, so usually they have specialized team who are making the things, like there will be like a team of PhD guys, right? Usually they are the PhDs, and they are the ideation guys, like they are making the core technology. You have to be a PhD from a very good reputed thing, so that they are making a very core technology things. And then there is a CRD department who is basically making the product, like basically making the idea part of it, like proof of concept that we can use 4 gigahertz or 6 gigahertz for Wi-Fi, right? They will propose that, okay, these are the research papers, these are the patents I have paid, and these are something like 6 gigahertz Wi-Fi is possible using this. Then it will come to actual corporate, then they will take the help from them, and then they will see the existing specification, derive their own specification and all this thing, and then they will start developing on top of it. But it is very systematic process. You don't go haywire here and there and all do all this thing. You have very specific amount of job, you have very specific skill set required for your job, and you will be developing on top of it. So the disadvantage of it is, you one day you say you are like a programmer, the another day you cannot say that you want to be a tester now. Okay, because you are a programmer and you are going to program.
hmm.
So you will be limited to your functionality, right? So I can tell you, like, in Bosch, when I was working in Bosch, we were working on ESP, if you know, electronic stability program, which goes into your car, for ABS, TCS, hill hold control, everything in the car. Like, I think like around 50 to 70% of everything Bosch was mechanical is completely converted into electronics now, right? And everything is being written by like mechanical and software engineers, mechanical, electrical, electromechanical engineers, you can say. Basically they are writing all the software on top of it. But I can tell you, like, for a single ESP, you can say a single ESP as a single microcontroller board, we were close to 1,400 people working on a single microprocessor, like a single board. Okay, so 1,400 people working on a single board, you will be confined to your area. Like, you will get one function or one domain out of it, right? You will. I got a breaks. Basically, cooperative regenerative braking was the domain which I worked on. Okay, so what was that domain is basically whenever you brake the vehicle, it will regenerate the electricity back, which will be used to charge the battery, right? So I was knowing from, like, that cooperative regenerative braking was my field, and I was very much accustomed to that only. I don't know how TCS work. Okay, I don't know how hill hold controls will work. I don't know how the physical implementation is there. Okay, I have not seen the PCB. Okay, I have not seen what microcontroller they are using. I have not seen what microprocessor they are using. I am just writing a software on top of it, right? So physically I understand, okay, this is the signal coming, this is my brake force is getting applied, this is how much I am regenerating the electricity and all. But maybe I have not seen what is that generator or how does it look like. I have not seen what is the physical connection of it. Okay, because that is not my part. There are like 2,000 more people sitting around with me. Maybe one of them is basically specializing only in connecting wires or making sure that every customer is having correct wiring technology in that,
Yeah, so
right?
at these times, like satisfaction becomes a little bit rare, no?
Work satisfaction is like, yeah, like you can say that work satisfaction is like, what I have always been feel is like, the smaller thing you work on, the more visibility you have. Because I can tell you that when I started working in consumer electronics, earbud chipset, you when you compare an earbud with a car, right? It's a huge difference. A car is having so many CPUs, so many things, that and all. Okay, and when I work on a single earbud, I think I have really more visibility what is happening everywhere, right? Because like the product is small. A smaller product is basically helping me out, that even though I am into an application or DSP, just a minute, even though I am into application or DSP, I can always contact to Bluetooth guys. I know how many Bluetooth people are there, right? So I think for a complete chipset of a earbud, all over the world, we are only 300 people from end to end design, from the specification to end customer engineering services. We are like 300 people. So it becomes really easy. You know, the second person you want to ask to, like, you want to understand something in Bluetooth, you know the person, right? So
Yeah.
I think the smaller product helps you understand better visibility, which was more important for me for from work life like satisfaction perspective. But there are like different perks of like having into bigger product and all. Like you, many times people actually don't want to understand the product, right? So it's good, right?
They
It's
just
it's
want
No,
to learn.
broad.
there is a lot to learn, like from that big team.
Yeah.
Okay. So, like the next question I wanted to ask that sometimes we write code. There's a popular scene about that in a famous web series where when we write some type of code. So generally, when we are college students, we try to when we are stuck in something like a big mess, we look up on Stack Overflow or Stack Exchange. Maybe
Uh-huh.
some open source GitHub repository is there. So.
Yeah.
Is that really a situation that you
Yeah, like, okay, I would say it's a really situation. Okay. From electronics point of view, the where I work, I won't say it does that help. Whether it helps me a lot, no. Okay. Whether it helps my wife is basically an full stack developer, in server domain. She is also in security. Whether it helps my wife, yes, it surely helps her a lot. Okay. From electronics point of view, the technology what I am working on is really not that open source that everyone is working on that and everyone is actually willing to share their solution. a lot of times you will get a coding solution as such, right? But you will, like, I can tell you, like, I'm suppose I am working, I'm giving you current situation, I'm working on a memory which is being designed by Qualcomm. Okay, so the memory structure, from the physical structure to end hardware, everything is proprietary. Okay, you don't know anything, like no one knows that anyone can make the memory like that. Okay, so what is the problem is, whenever I'm writing a driver for it, whenever whatever registers I'm using or whatever APIs I'm writing for it, basically I am having certain set of registers, I am having certain set of coding things I am coding on top of it. If I try to search on internet, it will say that nothing is being found, right? Because you, no one has made that memory except Qualcomm, right? So the thing is, lot of times you will get a hint that okay, you are getting this error and maybe this error is due to this problem. But a lot of times you will surely, like, I rarely, like, in 4.5 years of my experience with Qualcomm, I think I have rarely seen Stack Overflow for anything, because I know nothing will come out of there. But I believe a lot of my colleagues who are making CI systems, right, who are making the test automation servers, like test automation scripts and all those things, they are actually using it very heavily to rely on Stack Overflow and all those things, so that basically they are taking some privileges from there and all. But there are very heavy restrictions on how you can actually use it. There are heavy softwares which are being run, like there is a certification gate you have to pass, right? And the certification gate is basically, they run a software and they check everywhere in the internet whether you have copied from somewhere. And if you have copied, you are basically doomed, man. Like, basically you get a warning from very high thing that you are basically being copied the code, so you are not allowed to copy the code, right? It's never being allowed. You, once you copy it from internet, and someone finds it out that you have copied from the internet, you are doomed. Okay, so at least Qualcomm does not encourage copying from internet. Actually give you the hint that okay, this is the problem, this is the solution, what people have solved it. Maybe you tried the make the solution, you cannot actually copy the code, right? That's the end.
Yeah, in audience, anyone want to ask questions, they can go ahead.
Hopefully I did not bore you guys, like
No, no, no. Really, it was very interesting. We always hope some in our college days, like that someone like you would we get to talk to someone like you and get the real scenario instead of the rumors. Like, so it was very, yeah, nice
I
to
can I
hear
can tell
from
you
you.
that the look, I can tell you, like, a lot of times what happens is, um so it's like a vegetable market, right? You want to buy vegetables, suppose, right? And you are being given a task that you want to buy, suppose, 10 kg of 10 kg of brinjals, suppose, right? If you go to your local shop which is near to your house, you might get not get the same cost as you will get into the vegetable market, right? So once you are, I have been telling this to everyone I met, right? Once you are into electronics and you want to make your career in electronics, you have to go to place where electronics is valued, right? Um, I belong to Maharashtra. I was in Nagpur for even I did my engineering from Pune. I can tell you, right? I gave you that I gave 150 companies for interview, right? Out of that 150 companies, I think hardly anyone was actually working on electronics, right? So everyone who was evaluating me was evaluating on some background which I really don't know, right? I was not from C++ or Java or SQL or database, and if you ask me that how to inject that this thing in SQL database, I was completely blank, man. Like, how do you expect I study an engineering 4 years and I should know that how should I inject this in SQL database and all, right? But what I figured it out is, like, there are certain specified area where you have jobs for electronics, right? People, I would say Bangalore and Delhi and Hyderabad, these three places I usually find are lot of openings are there. And if you're in this field in electronics and having passed through 1 or 2 years in Bangalore, after post COVID situation, I have seen 2 years of experience getting minimum of 6 offer letters from different companies, and that guy choosing where he want to go to. Okay, that is the current situation in Bangalore. Like, you can imagine that getting one offer letter is also so difficult, and when you're getting a 6 offer letter means you have at least given a 20 interviews, right? And that's the thing, like, when I was searching for a call, I didn't get anything in Maharashtra. I got it in Bangalore. And that's the thing, like, if you are you should be flexible enough. You, if you really want to become an electronics engineer, or you want to become a pursue something in semiconductor, you have to switch the place and come to a place where your skills will get valued, right? Basically, even if you're going for GRE, even if you're going for your masters, I would always say that you take any university, but take any university which is located in Silicon Valley. Okay, you will go to some East Coast, you will go to some Texas or anything, right? And then ultimately you will come to Silicon Valley only. I have seen a lot of people who were doing their engineering from average college, but from Silicon Valley, were getting placed so easily, that as compared to having a better college in some other thing, right? I can tell you the same thing, even in even in Bangalore. A lot of times people think that Robert Bosch being an core company for electronics engineer or mechanical engineers and all those things. I can tell you every local college here in Bangalore basically consider Robert Bosch as master recruiter. Okay, so that is the situation here. Whenever Bosch comes to any company, they take 400, 500 people. Okay, and when I was in my engineering, even getting a call from Bosch, it was like, even a single guy getting into Bosch was like something like, oh, we have achieved something, right? That is the situation. Like, here, there are resources are scarce, so you always go to a place where your skills will get valued, right? So if you are planning to be in India, you have to be in Delhi, Hyderabad, or Bangalore, for Silicon at least. If you're planning to be in US or something, I would personally prefer go to Silicon Valley, right? So that's my take.
Right. So,
Hello.
what?
Hello.
Yes, yes.
Yes.
Hi, Ramesh.
Yes, sir. I wanted to ask that do we have to means in company does meetings happen to means too much frequently? Means we have been reading on internet that they are preparing. Means we have to prepare a lot of slides and take part in meeting almost every day, something like that.
Yes, so I would say is like, we do have to participate in meeting every day, day to day life, and all this thing, right? I would also say is they are really helpful. Okay, how they are helpful? I can tell you that I'm a firmware engineer, right? But being a firmware engineer, I know how to code firmware things. I know how to code registers. Okay, but know what is the hardware, right? When Qualcomm has developed their own memory, right? Uh, I get only one documentation, which is like one page that we have developed one memory, which looks like this, with hundreds of jargons into it, and I really don't understand. Okay, what is that thing? Like, whenever you will read the memory, whenever you will read the fuses, it will give encrypted data in SHA 256 with this specification, with this key being used. Okay, what do I make the thing out of it? I don't know what is SHA 256. I don't know what memory structure is. I don't know what fuses are, right? So I basically have to contact relevant people to get the information. Okay, when they say fuses, what does that mean? When they say memory location address, what does that mean? When I say I am reading a specific row, specific fuse, what that fuse corresponds to, right? And this information is something like I might not get directly. It's most of the time it is going to be a technical meeting. Like, very least amount of time it will be kind of a management meeting, right? So in a management meeting you will be telling what you are doing stuff and all, but I think it happens once a week or something. But every other time is like you are contacting people and talking to people to understand your things better. And you are also being put, like, you are being a firmware engineer, middleware engineer and application engineer will continuously ping you, man, what you have written in this driver, what does that HL do? This HL does not work in this situation, whether it is documented somewhere. You are a part of a bigger system, and the only way to grow is you help others and get the help from others, right? So if you don't do that, uh, basically you get screwed up, because like the appraisals is basically happening, and like you give feedback to 20-30 people, and then they give you a feedback, and then basically that decides your appraisal. So if you are not good to people, they will screw you.
Right. If anyone want to ask further, they can.
what are the challenges that face when we lead a team? How to maintain a team?
Okay, from the management perspective, look, I'm not led the team as of now. Okay, so there are different structures and together, right? Every organization is having a different structure. So I could say that if you're going to some organization which is a process-based organization or service-based organization, the career path is really fixed. Like after 8 years down the line or 10 years down the line, you're going to be a manager, and you actually don't have to code and all those things. Okay, but when you are into a technology company like Qualcomm, nothing is guaranteed. Like the people I work with is having 20 years of experience, and they are sitting also with me and coding, right? There is no saying no, that okay, they are not going to code, I am having a 20 years of experience, now I will not code. This will not happen. Surely it will not happen. If that guy says like that, he will be kicked out first. Okay, even though my principal engineer, my director, they also know coding, and they also, what, when I say coding means they know their shit, right? They are basically technical, right? Even though they might not be and coding stuff, they will be able to help you out into the things. um Line management perspective, what you are saying, a managing team and all those things, I might not be the best person to say that, but it is like, I would say it is one of the very difficult job to get the work done from someone else, right? I feel it is like really difficult job, because when you're responsible for your job, you know that you have to do it and you do that, right? But you want to take the work from some team of 5 or 10 people or more people, right? So it becomes really difficult for them, like for basically a manager to convince them that you do this. So it is a difficult job, I could say. But different challenges and all, I would say is like, everyone is having different perception, different aim, different goals in their life, and satisfying everyone is, I think, is really difficult, what managers usually have to do. And if given a chance, I will never become a manager. I know that.
Okay. Thank you very much, sir, for your time. I guess we have emptied our mind with all questions, and if new questions arise, we will ask you.
Surely, you can surely reach me via Kathan. He has my number and my email ID also, right? I'm also in Discord, so you can contact me on Discord also, right? So ultimate ultimate final concluding thing I would say is, you learn skills. If you see that your engineering did not provide you the relevant skills, so first question comes out is, what skills I should learn? Okay, you just go to that company website, go to the career page, and see all the profiles you are interested in, right? Where and how you can acquire it. Okay, either you join a CDAC, or you join some institute which teaches you, or you learn it on your own on course or academy, Udemy, or anywhere, right? Anywhere you learn, it should reflect in your resume, and that will take you to the point. You look, you cannot say that you are an engineer, and if I find every one of your resume to be same, I'm going to select no one. Your resumes has to talk to what basically I'm looking into, right? if I am looking into semiconductor, I am looking as a physical design engineer, or I am looking as a firmware engineer, your resume should have a mention of at least a firmware engineer. You cannot say that I have done an Python course and I'm looking for a firmware engineer. I would surely consider you for firmware test engineer because that profile matches, right? But I cannot say that you want to be a firmware developer and you are having a Python engineering, right?
There
I
should be
cannot.
clearance, you can say.
Yeah. So basically, the same way, physical design or anything, like if you have worked on physical design, if you have worked on testability, if you have worked on DFT, basically that thing, even the name should come, right? I can tell you that if even the day you are able to write, Bluetooth ATT, GATT, okay, lower layer, physical layer, data link layer, okay, on the data link layer protocol or networking layer protocols of Bluetooth, or you have even mentioned that you have worked on lower stack of Bluetooth or upper stack of Bluetooth. I think the next day you will start getting calls from the company. They will not really look into how much experience you have or like that. Okay, so just see what skills needs to be, what you need to have by going through the career pages and seeing the 2 years down the lines what is the skills you require and whether you fit in that, and try to mention that whatever skills, convert them into your skill and mention it in your resume, and then search in a proper location, right? You cannot say that I am sitting in here, I don't know, like you cannot go to New Zealand and say that I want to do a job in semiconductor. There are, like, even if you cannot count 5 companies of New Zealand who are into semiconductor, you're searching in wrong place. Search in the right place. You have to be either in Malaysia or Singapore or US, or if you are into automotive, then you have to be in Germany, so that you will get hired easily, right? The amount of opportunities will be really easier if you are into the right place. So having a right place, having the right skills, and having the right skills mentioned in resume is really important to get selected. Okay, so hopefully it helps. uh,
It's lot.
sure.
Okay, I hope
Okay,
everybody enjoys the session.
you can always contact me, like, on Discord. I'm
Yeah.
always there,
We
right?
usually have the Sunday meet on Sundays, like everybody present their projects and kind of. You can come over.
Sure, I will try to, but I can tell you that I'm doing my masters as well. Uh, just a minute.
Yeah.
So yeah, like I'm doing my masters as well, along with, after 8 years of experience. I'm doing my masters along with my engineering, along with my job. So it becomes really difficult for weekends and all, because weekends I have
Yeah.
the classes and
Before
all.
the-
So I will surely try, right? Because I feel this kinds of forum are really nice. Like, you talk to people, and basically I will get a lot of things, as you guys, like the questions you ask, right? I can imagine like what situation or how you are thinking, how I used to think, and how suddenly things are being changed. So if you have the clarity on what you want to do, it will really help. Like, wrong choice that, being an electronics engineer you are going to computer science or you are going to some service based engineer. There is no wrong choice, right? I won't say it's a wrong choice. Everyone have a choice, and you choose what you become. I chose
Yes.
initially as a
Agree.
computer science engineer, Android Java developer, then to firmware. So it's like, it happens, usually it gradually happens, and you have to be just firm on what you want to do.